Our objective here is to write the inverse of this given function as well as provide domains for both the current function and its inverse. Let's talk about the domain of this guy first. It's a rational, which means I have to be aware that I can never divide by 0. So this will work as long as x plus 4 does not equal 0. If that should happen, this function breaks. When I go to solve this, I effectively am saying that x cannot equal negative 4. So one way to write my domain, if I'm going to use set notation, is to say that the domain is the set of all values of x such that x is not equal to negative 4. And that's what this statement would read as. X is the set, so the curly brackets, of all values x such that x is not equal to that negative 4. And that covers this. Now let's talk about that inverse. If you remember the process of inverse, first step is to replace f of x with y. Because when I graph, I always put the output on the y-axis, the input on the x-axis. So I'm going to go ahead and rewrite this as y is equal to 1 over x plus 4. Now I'm going to go ahead and I'm going to switch the x and the y around in order to create that idea of flipping the process. So x is now equal to 1 over y plus 4. Remember, my objective is to isolate the y now. So I'm going to take this, it's a proportion, I'm going to cross multiply. So I'm going to multiplying these guys and that. That's going to give me x, y plus 4 is equal to 1. Divide both sides by x. Y plus 4 is equal to 1 over x. And now subtract the 4 from both sides. Y is equal to 1 over x minus 4. So that means my inverse would be f inverse of x is equal to 1 over x minus 4. I can also check this. For example, if I plug in a number here for x, I can see what kind of an output I get. When I put that value back in here and run it, I should get my initial input back out again. Let's talk about domain. What values are going to break this? Well, I have a rational here. I have 1 over x. And again, for rational expressions, I'm not allowed to divide by 0. So the one limitation on my domain is that I can never have this denominator be 0. So my domain is limited by saying that x itself cannot be 0. Or another way to write that in set notation is that the domain is all values of x such that x is not 0. So I have my original function here, its domain, the inverse is here, and its domain. I can also lastly ask the question, is this truly going to be a function? Or, if I were to look at this on a graph, will it pass that vertical line test? From what we've done in previous chapters, I know, looking at this graph, I'm going to have something that is not going to be double up anywhere. This is going to give me 2 lines with an asymptote, and it's all going to be shifted down. So it should pass that test, and itself is indeed a function.